Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Akmal Ijam binti Rahmat. Today my group will discuss about floating concrete and my part will be discuss about introduction. Okay, the introduction about the concrete. Concrete is the most widely used material, composed material in the construction industry. It is durable, weather resistant, environmentally neutral, and economically affordable. It is also a mixture of Portland cement, aggregate, which is gravel and sand, and potable water. Fresh concrete is a workable, formable, non-toxic paste that can be easily poured and formed as per design requirement. Okay, for the reinforced concrete, despite the amazingly high compressive strength, concrete, like all ceramic, lack the tensile strength. To improve this physical property, concrete is reinforced with steel rebar and more recently with static fiber or composite rebar. Lastly, about the floating concrete structure. A floating concrete structure is a solid body made of reinforced concrete, an inner change of chamber filled with a lightweight impermeable material, typically polystyrene. The advantage of floating concrete structure lie in the economy of the material used, which is concrete is very well suited to a marine environment, in the fact that it is easy to make concrete structure buoyant in the construction stage as well as permanently for a safe permanent installation, and in the fact they can also provide storage space. The requirement first is to stay float, loaded or unloaded, to remain in the service for 20 plus years, to stay in designated inclination for its service life, no matter how load distribution, current load, impact load, wind load, or tidal fluctuation are applied to the structure. To be reconfigurable, the owner can reconfigure the structure or even move the structure to another location to make the users and passengers feel the safety and comfort of standing and walking on a firm ground, no matter how stormy sea is or how big a passing by vessel is. Thank you.
Assalamualaikum, and my name is Nur Najwa, and I will represent about the floating concrete durability. Okay, in this slide, it consisting three items, which are environment challenge, design consideration, and the composition of material. First, I will represent about the environment challenge. Okay, the environment challenge. As we know, when the concrete floating is exposed to the environment, the deterioration of the effect will be affecting the concrete floating structure. Okay, for the first, the rate of corrosion of steel is dependent on the availability of oxygen, which is mean the floating concrete that exposed to the environment in the tidal and atmospheric zone, the oxygen is present in adequate quantity, and it will lead the corrosion of steel much faster. Next, in the portion of concrete structure above the sea level, the seawater rise upward by capillary action, which is mean in the progress of wetting and drying cycle of the salt in seawater, when the tensile stress is exceed the tensile strength of concrete, the disintegration of concrete surface will take place. Okay, the next, due to the fluctuation of seawater level, the leach salts and corroded concrete fragment gets washed away, and the erosion of the concrete takes place, which results in the loss of concreteness. Okay, the last is the mechanical impact of the sea wave in active tidal zone continuously increases the wear and tear of the concrete. Okay, this table shows the different type of attack zone in the marine environment. Okay, the first is the atmospheric zone, the second is tidal zone, and the third is submerged zone. Okay, From this table, you can see the type of attack that exposed to the 3 list zone. Next, the design consideration. The next is about the design consideration. Okay, there is a few considerations that must be taken, which are the dead load, life load, wind load, hydrostatic pressure, including the buoyancy, the effects of temperature and tidal change, wave, sea quake, ship wave, tsunamis, and effect of marine growth, which are corrosion and friction. Okay, the second is the adequate design of mooring system. The mooring system is needed to keep the position of the floating structure and minimize the mechanical impact of the sea condition. Okay, this is the figure. Yep.
Okay, my name is Wan Sarifah Nasro, and I will present about the floating concrete, about the application of floating concrete. Okay, there is a two types of floating concrete. First is semi-submersible type, and second is the pontoon type. Semi-submersible type is raised above the sea level using column tubes or ballast structural elements, which to minimize the effect of wave while maintaining a constant buoyancy force, and thus they can reduce the wave induced in motions and are therefore suitably deployed in high sea with large wave. And then floating oil drilling platform used for drilling for and production of oil and gas is an example of semi-submersible type. And then when this semi-submersible are attached to the seabed using vertical tethers with high pretension as provided by additional buoyancy of the structure, they are referred to as tension leg platforms. Okay, for the pontoon types, there is a pontoon type floating structure lying on the sea level like a giant plate floating on water, and is very contra with the semi-submersible type. And pontoon type floating structure are suitable for use in only calm water, often inside a cover or a lagoon and near the shorelines. Okay, large pontoon type floating structure have been termed megafloat by Japanese engineers. Okay, megafloats are floating structure which at least one of its length dimensions are greater than 60 meters. Okay, next I will show about the application of floating concrete. First is a floating bridge. White Canal floating bridge was built in 1963 with a length of 1,988 meters. In Nordland floating bridge, Norway, West India Quarry footbridge, United Kingdom, Helens Point, and Yumei bridge in Japan. Okay, next is the floating entertainment facilities. Okay, floating island at Onomichi, Hiroshima, Japan, is a very large floating island with a size of 130 meter times 40 meter times 5 meter, and this amusement facility has a 3D visual image, theater, an aquarium, and a marina. Okay, next is a floating restaurant in Yokohama, Japan. Okay, is size with 24 meter times 24 meter times 5.2 meter pontoon. Okay, next is the floating storage facilities in Shirashima floating oil storage base, Japan, and Kamikaze floating oil storage base, Nagasaki Prefecture in Japan also. Is a very large storage facilities, has been used for storing fuel, and this is keeping the explosive inflammable liquid from populated areas on land. And in Japan, there is two major floating oil storage system, with Shirashima floating oil with 5.6 million kiloliters, and in Kamigato with 4.4 million kiloliters. Okay, next is floating emergency facilities. Okay, these floating structure are inherently was isolated from earthquake-prone countries, is especially in Tokyo because it's suitable for the rescue bases, and it is an emergency rescue base in Tokyo Bay and emergency rescue base in Osaka Bay. Okay, next is a floating airports and mobile offshore base. Megafloat in Tokyo Bay, Japan, and proposed floating in runway Tokyo International. Megafloat has awarded as largest man-made floating island in World Guinness World of Record. And that's all for the application of floating concrete. Thank you. As the conclusions in this topic, there are many use of floating concrete structure as well to save the land use area. Although many considerations and material compositions should be followed, the construction of the floating concrete today have good ductility against the physical, chemical and mechanical attack from sea threats. As an example, in Japan are the one country of major user of floating structures. The use of floating concrete structures also can be expanded and constructed in Malaysia. The construction of this floating structure in the coastal area can contribute the fishermen best platform to facilitate their jobs. Okay, thank you.